Hello, welcome back. In this segment, I wanted to briefly introduce you to the notion of serialization and deserialization. And then I will explain some security vulnerabilities if you are not careful at the time of deserialization. Okay. I decided to create simple programs to illustrate the problem. So let us look at serialization first. Okay, I have a program called serial main, right? Which is a main method. Here you can see here there's a main method, and we are creating our customer info object here and setting two of the properties like customer and the contact name. And then we are using a utility which serializes this object into a file. So when you serialize an object, you get a binary stream of data. It's kind of binary, not exactly binary, but assume it is binary. And we are writing it to a file called customerinfo.bin. This is serialization. You have an object, you convert it into a stream of bytes. Yeah, that becomes serialization. And those stream of bytes are saved into this file in this case. Okay, let's look at the customer info very quickly. It's just a small class, two attributes, right? Customer and contact name. And we can get customer, set customer, get contact, set contact names. Okay, and that's basically it. And we can go ahead and let me remove the existing file custom info.bin, right? So that you can see if I compile the serial main and then I run it, right? It will show you a file called customer info.bin. Yeah, it is just created at the time of recording. Okay, so the file is created. We can take a look at it. It's not beautifully readable. It has some special characters like non-typable ASCII characters, but you can see our data like Donald, Canon, those are all things that I put in inside our main method. And we can see that we are serializing the class name customer info. Okay, this is how a serialized stream will look like approximately. Okay, let's do the deserialization now, right? I have written a little program for deserialization also, which takes the opposite direction, right? Which takes a file as an input and gives you back an object. And that object is of type customer info. So there is a security problem at this point, right? At this point, because we are trusting this file. Whatever the file has, we convert that file content into an object and then we cast it here. Okay, so I'll illustrate why this is a problem in a moment. But first, it's important to understand how deserialization works, right? Your binary is converted into an object, and then you can call the getters and setters of that object to display or analyze or change the state or whatever, right? That's essentially what deserialization means. It is going backwards from stream to object state. So just to complete the demo, right, let's quickly compile this and run and see whether we can get back the same data we serialized. Yeah, so I'll compile this and I'll run this thing and we will see. Yeah, you can see here I got back customer name, contact name, and so forth, exactly the way we have it in the serialization code, right? In the serialization code, you can see here I have these two attributes, and exactly the same attributes come out when you deserialize. So that's basically how serialization deserialization works. This is the same concept in other languages, although you're seeing in Java. C# has something very, very similar. Okay. So I mentioned there's a security problem. Let me explain why. So you can see here in the deserialization main, right? We are trusting the content of this file. Whatever the file has, we will trust it. We will deserialize it and get an object back, and then we cast it. So let's do some small changes to the customer info.bin. So instead of serializing the customer info.bin, I wanted to serialize another file, let's say victim.bin. Yeah, I'll show you. I have created a file called victim.bin using the help of a victim.java file. Okay, so as long as this victim file is part of the class path of the target that you're trying to attack, this idea will be applicable there as well. Yeah. So here is the class called victim. It implements serializable. And we have two private attributes, I and j. And there's a private method, and then there's a static block. Okay, so now let's serialize this and write it to a file called victim.bin. This is exactly what this serialized victim is going to do. Right? It's creating an object called victim. Okay, And I don't need this iVictim for now. We can just live with it. We will write it to a file called victim.bin. So let us compile this thing now. Java C serial victim. Okay. So Java serial victim dot. Okay. Now we have just finished serialization, right? We can see what is the file it created. It created a file called victim.bin at this time of recording. It's exactly the same time as you can see my VM has. So the victim.bin is created. Now I'm going to copy victim.bin just for the demo purpose, right, into the customer info.bin, which is what the program is expecting. But we are now simulating the fact as if that an attacker was able to modify the content of customer info.bin, right? This is much easier to do it rather than setting up a network interface and having a web application, all those things. If the file is not protected, right, in this case, the customer info.bin, assume it's not protected, attacker can write to that file just to get the idea of a deserialization across. That assumption is a fair assumption. So we are going to make the program do something for us now. So what I'm going to do is I'll just copy the victim file into the customer file, right? Customer info.bin. Then we deserialize the, let's deserialize the customer info.bin, but it's not really customer.info.bin. Remember, it's victim class now. Okay, you see here, deserialization worked successfully. Some people are misled by this warning, this exception rather. I will explain why it is misleading, right? It says you're trying to cast victim into customer info. Okay, so if you go back to your deserialization main code, right, you can see here we are casting it into customer info. But what we send in here is not customer info. We are sending victim class. That's the reason class cast exception is coming. That means you may think at the beginning, okay, everything is working fine. Just an exception is coming if somebody sends us malfound file, invalid object type or whatever. But that's not the point. The point is to show you something more important, right? What is important is this particular thing. If you go out here and you see here, and let me run it again, you can see here my static code got activated, right? Static blocks got activated. Nobody's calling the static block explicitly, but it magically got activated. And the reason for that is very simple. If you look at the victim, right, the victim has a static block. So any class that is on the target machine that you're trying to attack has a static block as long as that class implements serializable. If you're allowed to submit a stream of bytes to the target, you can use any victim, so to speak. Although this victim is useless, more or less, it just prints some system.out.println, right? But the idea is generalizable. As long as you are finding a good, some people call it gadget, then you can submit that and get some remote code execution depending on your context. Okay. All right. So how can we stop this? Java 8 has an interesting idea called jdk filters that will allow us to stop deserializing object types that we don't expect. Okay, Java 9 and more recent versions of Java at the time of this recording have much more interesting ways to handle this, many interesting options, but I'm going to stick with a Java 8 option just to start with, yeah? So in Java 8, what we can do, there is something called jdk filter. This is the jdk filter that I'm going to leverage. This environment variable, jdk serialize filter, I'm setting it to customer info, right? That means I'm going to only serialize a class called customer info. My customer info is in the default package. That's why you don't see all the com dot blah blah. But you get my point that this is just a class that you wanted to allow for deserialization, and you can add more classes with a semicolon as a delimiter. And if you put an exclamatory mark at the beginning, that means you are not going to deserialize anything other than customer info, or any other things will not be deserialized. That is the meaning of an exclamatory mark with a star. And I need to put a backslash because semicolon and exclamatory marks are special characters on Linux command line. Okay, so that's basically it. Now let's see whether our victim will run in this case. Hopefully it's not running. Let's just confirm that, right? So all I have to do is just enter this. And as you can see here, victim is rejected because this is not what we allowed in our filter. And that is why we are not getting the static code and the default and other things that will magically run, like read object code and so forth. Like if you see the victim code, right? Again, we have a static block and we have this private read object. All of those things got activated without the filter. Now with filter, it stopped. Your deserialization process is very strong because you define a filter. If you look at serialized filter, right, it's operating across all the classes within the current process. Okay, that means if you forget to put any class here in your allowed list, this is kind of allowed list, right? Let's say you have a product that uses 100 other libraries. Somewhere in that, they may be doing serialization, deserialization, who knows, right? That will also be stopped unless you put the class names that you wanted to allow for deserialization. So this has to be carefully used if you're using it in production, right? This is at a process level, like one instance of Java, it's applying this filter for all of the classes within that Java instance. Okay. It is also possible to apply across all projects you have, independent of whether I'm running it in this one process. Let's say you have multiple processes. There are multiple Java running in background, and you want this kind of filter applied on all the process, then you can define JDK security policy where you could specify such a filter that will be applicable for all instances of Java within your project. Okay, to summarize, if you use Java minus jdk serial filter or equivalent of programming way of defining this key value pair using properties file or whatever, it will apply this at the time of deserialization. Only the classes that are listed here will be allowed. That's all. Thank you very much for your attention.